All right. So now that we've learned how to draw a Lewis dot structure for a single element or atom, we're now going to start getting into compounds, or basically chemicals that have more than one type of element in them. Specifically, we're going to start with ionic compounds, or compounds where instead of sharing electrons, one atom in the compound takes the electrons of one of the other atoms in the elements, forming two ions, hence the name ionic compound. So let's get started. We're going to work with one of the most well-known ionic compounds, sodium chloride, NaCl, aka table salt, that stuff you love to dump on your French fries. So our first step is to determine how many different atoms are in the structure. So that means we're going to have to count these subscripts, or little numbers. Now you'll see in this particular example, we don't see any little numbers. We could, if we really wanted to, write subscripts of 1, but when there's just one of each atom, we generally just don't put a subscript at all. So we have one chloride atom, or chlorine atom, and one sodium atom, right? If this was some other compound and we saw a subscript of 2, that would mean we had 2 chlorine atoms. So that's what that would look like. But in our case, we have some invisible subscripts here, which means we have one of each atom. All right, next step, check. We need to decide how many valence electrons are in each atom and total them up. So let's go to our periodic table. You'll see I've already highlighted sodium and chlorine. Sodium is in the first column. That means that it has one valence electron, or one electron in that outermost level. So in the third energy level, has one electron. Chlorine is in column 17, aka group 7A. So it has 7 valence electrons, 7 valence electrons. So there's a total of 8 in this compound. So I'm going to go ahead and put my VE total here and put 8, so that I remember I have 8 total valence electrons. Remember, pay close attention to where we're putting them as we draw this structure. Then we're going to figure out the charge of each atom, because since this is an ionic compound, it's a metal, sodium, with a non-metal, chlorine. One of them is going to gain electrons. One of them is going to lose electrons. So one of them is going to gain and become negative. One will lose and become positive. So, let's go to our periodic table. Now, sodium, you'll see, has a much lower ionization energy, right? Because it's all the way over here on the left side of the periodic table. So it is going to definitely lose its one valence electron to get a positive 1 charge. And who's going to gain that extra electron? Well, the very electronegative chlorine. So it's going to get a -1 charge. So my sodium is going to get that +1 charge. My chlorine is going to get that -1 charge. All right, now let's actually start drawing our symbol. So we're going to write the symbol for each element and place brackets around it. So here's my sodium, bracket, bracket. Here's my chlorine, bracket, bracket. All right, check that off. Then we're going to write the charge of each ion in the top right corner outside the brackets. Well, I already found those. So +1, -1. Done. We're almost there. All right. Now, the last thing is, inside the brackets, we're going to begin placing dots on the fourth side of the symbol, adding clockwise until all valence electrons are placed, just like we did before. Now remember, sodium has lost its one valence electron, so we actually don't put any dots on sodium. So let's do chlorine, which is now going to have, instead of just 7 valence electrons, 8 total valence electrons. So 1, 2, 3, 4, 5, 6, 7, and 8. And I will subtract those from my total. We have used all of our valence electrons. We can check. Yep, we used all of them. Chlorine is happy as a -1 ion. Sodium is happy with its +1 charge. We are good. This is our complete Lewis structure.